Alright, time for another Draft Science video presentation. So, a response to a Sabine Hossenfelder. Disappointing. She's really gone completely gobbledygook. I mean, her catchphrase is physics without the gobbledygook, and it's just, her fundamental understanding of reality is gobbledygook. And so this whole, there's something confusing about time, like we have to make time a dimension, like time can't be understood as just a simple function. That's just the byproduct of the fact that stuff moves through space slowly. That's the simple truth. The fastest thing in the universe isn't instantaneously fast. It has to get from one point to another point in space, and it takes time for it to get there. It moves at a speed, and that's why there's time. If it moved instantaneously, then everything would happen all at once and it'd be all over already. Wouldn't even have time for the conversation because it would all happen so fast. So because matter has a speed limit, force, there's time. That's it. Nothing else.
Time is money. It's also running out.
It can also be wasted, and your videos are now officially a waste of time.
Unless possibly it's on your side. Time flies, time's up. We talk about time all the time. But does anybody actually know what it is?
It's just a function.
It's 3:30.
That's not what I mean.
Joke. Ha 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 ha. Time wasted again.
Then what do you mean?
What does it mean? That's what we will talk about today.
No, you're not going to get to it like now. Oh, you're going to wait some time to get to it. Oh. Because you have to do this first. Okay, so it says, well, is time real? I mean, obviously, it's, as Einstein would say, it's one hell of a, it's obviously one hell of an illusion if it's not real. But anyway, and it's science without the gobbledygook. I wonder if that's a German word. Because this is just idiotic. I mean, in the sense that this is just gilding lilies. This is just turning something so rudimentarily simple into something complicated for no good reason.
First things first, what is time? Time is what keeps everything from happening at once, as Ray Cummings put it.
Yeah, which is a good enough answer. Time is because everything doesn't happen instantaneously. That's why there's time. There's no such thing as instantaneous. There's no such thing as instantaneous. Therefore, time exists.
Funny, but not very useful.
I think very useful and frankly not that funny. I didn't think it was funny. I didn't even laugh a little.
If you ask Wikipedia, time is what clocks measure.
Well, Wikipedia is not the best person to ask, is it? No.
Which brings up the question, what is a clock? According to Wikipedia, a clock is what measures time. That seems a little circular.
Well, yes, you could have looked somewhere else and you might have found a little bit better definition. But yes, time is a consequence of things moving slow. Period. Period.
Luckily, Albert Einstein gets us out of this conundrum.
No, he doesn't. I mean, it's just nonsense. So time is a dimension. Some wacky place you can go. I can go to time. No, you can't go to time. No, time doesn't fit. It doesn't have a right angle. It's not a dimension. It's a silly word to use. It's a silly thing to call it. It has nothing to do with being a dimension. I mean, science is for a purpose, right? I mean, you have something like marsupial, and you have something like mammal, and you have something like reptile. You don't just arbitrarily throw things in these categories. They have to fit in the category.
Yes, this guy again. According to Einstein...
Yes, who cares what Einstein thought? I mean, really, you're so overdone. The guy's life was a mess, and his physics is a mess.
Time is a dimension.
It makes a mess.
This idea goes back originally to Minkowski, but it was Einstein.
Oh, no, it goes back all the way to where you got your idiotic, moronic formula for energy. It goes back to whatever his name was, Leibniz. The first relativist, you could sort of say, or somebody like him. They were already doing this relativity crap. They were already making up this fake notion that reality isn't real, and that somehow we're all living in our own little universes and we're doing our own little universe thing. And we're not in one big universe where all the atoms are and where all the molecules are and where all the electrons are and where all the protons are. One universe where they all have to interact with each other in the one universe. Yeah, they were already breaking all of that hundreds of years ago.
Who used it
For no good reason, by the way. For religious kooky reasons, by the way.
in his theories of special and general relativity to arrive at testable predictions.
Yeah, well, testable in what sense, right? So because the Eddington is a pretty crappy test result, okay? You never did the experiment a second time with better technology, and you certainly never took advantage of the 400 times better resolution in space. Even though you've had 50 years to use that better technology, you haven't done it. So that wasn't a very good test. And the other test, basically you're saying something stupid like, well, I can screw up a clock. Yes, so what? You can screw up certain clocks by doing certain things. I can ruin a pendulum clock by just dropping it in water. I mean, I can break a sundial by taking it out of gravity. I can break lots of clocks lots of ways. And you can break atomic clocks. You can break atomic nuclei. And all I have to do to break your clock is put some radioactive material around the radioactive material, and I'll change its half-life and change how often it shoots out the stuff, and it'll tell different time. So all I do is expose it to radiation, and it tells it that it gets the time wrong. And you're saying it's a big surprise that, hey, when you move the clock very fast, it breaks. Oh, gee. We proved it. No, you didn't prove anything. You proved you can break clocks. You didn't prove that time is differential.
That have since been confirmed countless times.
No, it hasn't been confirmed countless times. None of that has actually taken place. That's just part of your jargon. You used one clock and you broke it in one way. And there's nothing surprising about the fact that radioactive decay might be disrupted by high velocity. So this is the part where I think I will interject and give you an alternative theory of reality. And just point out how it really looks. Okay, not their storytelling about how they prove some theory. They didn't prove any such theory. So obviously, I'm all going to argue there's one universe, right? And every electron, every proton, and every single thing is in this one universe. And so the empty space between these things is the same empty space that's between the Earth and the Moon. Empty space is empty space, and matter is matter. And the little force bits that control it are the little force bits that control it. Okay, there's no way of evading these realities. So let's say you are a human on Earth, and let's reduce your humanness to you're a bunch of electrons and protons. You can get that idea, right? And so when your body moves, all of your electrons and protons come with it. The atoms, everything gets tied. They're somehow tied to each other, and wherever one of them goes, they all tend to go, kind of thing. So that's basically, and you're sitting here in a place in the universe, and at every second, really, where you're going is changing in absolute space. I mean, you're going around an Earth, okay? The Earth is traveling around a sun. The sun and the Earth are traveling through space, in a galaxy. You're doing a lot of different things are happening to your movement. I would argue it's this simple, right? So let's say all your atoms have a collective disposition, and all the things in your house have a collective disposition. That means that every single piece of matter, that is every proton and every electron inside of you right now, says I'm going somewhere. It's going somewhere right now. When I don't move my hand, all that kind of stuff. I'm just saying, any one moment at a time, if I could see your electrons and protons, there would actually be a signature of where they're going. You have an absolute velocity in space, and it has a signature. And every single electron, every single proton has that signature. These are supposed to be parallel lines. So every single one, every single electron has the same signature. It's all the same. They all have a vector, okay? A vector. And the vectors are made out of something real. These are real little pieces of force. And it's really an indication that more stuff hit it from one direction than hit it from another direction. So it piled up a bunch of this stuff. Because as you've been in the universe has, in a way, biased you in a direction. Okay, and so the next moment it's going to change because stuff is going to hit you from another direction. Because you're moving into stuff. That's a fact. You're moving into the universe. And by moving into it, you're moving away from some stuff and you're moving towards other stuff. So you're going to hit more of it. And when one of these new pieces of stuff hits, there's an interaction, an exchange. You know, this piece will be, this will now stick, and a piece over here will now leave. You know, well, this one actually leaves. It doesn't stick until there's nothing. So everything you're banging into is going to reflect, and it's also going to change the disposition of this vector. So if something does come in this way and reflects this way, what it's going to happen is it's going to bend that tail. You know, your little comet tail, you could call it, this little energy tail you have. It's just going to bend it slightly. So when this one reflects equal to this distance, that means it's going to turn your tail, and your tail is going to now become this tail, right? And because all the other parts are doing the same thing you're doing, moving into gravity, moving into the moon's gravity, moving into this, moving into that, they're being affected by the same kind of force changes. And so they're also going to change their tail. Will move a little bit over here. Okay, so they'll all move their vector of which way they're going. And as we go around the Earth, and as we move on the surface of the Earth, and we change our positions, as we change our positions, where that vector is pointing is going to keep changing. And if we can affect it with enough stuff, you know, we can have, you know, the person that is you can be affected differently than the person next to you, because you're on an elevator, and when you get on the elevator, a bunch of force is going to hit you in one direction. It's not going to hit the other guy. All right, so you're going to be affected by a whole bunch of force pushing up through your feet and pushing into all your atoms, and all your atoms are end up get a disposition, and they're going to change that vector again. So the vector is going to keep changing, and then when the elevator stops, the force is going to stop, and then it's going to go back to the old signals, and the old signals are just going to turn that vector right back to where it was before. So you're going to have the same vector as the guy on the ground again, you know. So you'll go on your little motion trip, the vectors will all change, and then when you stop, you'll just decelerate, and your vectors will end up being the same as everybody else's vectors, in the sense that you're getting hit by more stuff going this way than you are this way. And you're going to have a vector that shows that change, the fact that you're in a universe, and the universe is actually hitting you with more force going in one direction than it's hitting you with force going the other direction. So you're just going to keep going in that direction as long as that force keeps hitting you. As long as that bias in the field exists, and that bias in your atoms exists, you're going to maintain that direction. So as long as you have these extra bits, until something comes along to get rid of them, that is, you hit a lot more stuff in this direction to undo that, then all the cells, all these they've all acquired it, and it's going to take a lot of force to get rid of it. You have to get rid of it for all of them. You know, not just this tail, but you have to get rid of this tail. You have to get rid of this tail. All the atoms have that momentum, and you have to get rid of all of it, which means you have to hit this stuff with a ton of force to get rid of all of this, to make all of this reflect away, all of this stored energy. So, and that's why it takes a little time to accelerate something. It's because you really are changing it. You're physically changing every single one of these atoms. You're changing how the force is hitting them. Every single one of these elemental bits. But yeah, you have a real velocity in the real universe. And time is just the fact that the stuff hits you at a rate. Okay? The force is moving at a rate. The gravity, the magnetism, the light, it's all hitting you at a certain speed with a certain density, and you're going to be the byproduct of all of those effects. Yeah, I think that's good enough for this video. I don't want to dominate the video with that, but time is just the fact that you're interacting with a forces, okay, that are real. They're not fields. They're actual substance actually moving. And there's more of it coming one way than going the other way, and that's the difference. And your experience means you have stored a certain amount of the force. You have little bits of stuff, and to get rid of it, you have to interact with more force to get rid of it. More than you've stored.
Time is a dimension, similar to the 3 dimensions of space.
So again, it can't be similar in any way whatsoever, because the only thing that makes the 3 dimensions really have any character at all is the fact that they're straight lines perpendicular to each other. That's their real definition. You can't draw another line that's perpendicular to the other 3, so there's no such thing as a 4th dimension. It's a silly thing to even talk about. There's no place for it to be real. It can only be an abstraction, and it can only be a silly abstraction because it can't have nothing really in common with the other three dimensions. It can't have anything to do with being a dimension because it doesn't have the fundamental quality of being a dimension. It's like saying a rock is a bird. It's a category error, an obvious category error. Time doesn't fit the description of what a dimension does or is or has as properties. It doesn't fit in any way whatsoever. It doesn't belong in the category.
But with a very important difference that I'm sure you've noticed. We can stand still in space, but we cannot stand still in time.
So again, silly almost. It's so trivial, a silly thing to say. Of course, you can't do a lot of things with time. The time doesn't have any mass, and time doesn't have any this. It has lots of things. You can only have mass in these dimensions. You can only move in these dimensions. Time can't do any of that.
Time is not the same as space, but that time is...
Yeah, space is nothing. So again, what's the point? Space is nothing. Space is just a volume of nothing. That's it. It doesn't do anything. It doesn't have any properties. It's nothing. The stuff, the atoms, the molecules, the elements, the electrons and protons, they're the things that have properties. The space is the nothing between the things that have properties.
The dimension means you can rotate into the time direction, like...
Silly, just silly, right? I mean, it's just silly, right? Oh, I decided the time dimension is left and right. You know, I mean, there's two dimensions, right? Forward, back, left, right would be, you know, on the same plane. And where am I going to put time? You know, because up and down is here. Well, I guess I could put time here and pretend up and down is somewhere else, but that doesn't make much sense. Where again do I put this fourth dimension? Oh, that's right. I can't put it anywhere without extracting one of the other dimensions.
You can rotate into a direction of space. In space, if you're moving in, say, the forward direction, you can turn 45 degrees and then you will move instead into a direction that's a mixture of forward and sideways. You can do the same.
No, so again, there's no such thing as forward and all these things, right? So all you can do is move tangentially to two dimensions. You know, but there's nothing else you can do. And you can't call that one specific dimension any different than all the other tangents. None of them mean any more than the other.
With the time and the space direction.
I mean, whether you call up and down, left and right, it just doesn't matter what you call them.
And it's not even all that difficult. The only thing you need to do is change your velocity. If you're standing still and then begin to walk, that does not only change your position in space, it also changes which direction you are going in space-time.
Yeah, which is just nonsense, right? So this is the bullshit of the fake curved line and a fake dimension. So we're supposed to think space is a dimension, it's nothing, and time is a dimension. And obviously it's not a something. It's an event. It's not a noun, it's a verb. You know, it can't be a thing. Okay, because it's an event.
You are now moving into a direction that is a combination of both time and space. In physics, we call such a change...
Yeah, you should just call it a bad idea we should have never played with. We should go home and start over because this is a really bad painting. This is really illogical mush, abstract, retarded crap. And if you had any brains at all, you would have given up on this nonsense a long time ago. You'd hear it and say, oh, that's too silly, and then you'd decide, I'm going to go try to find the right answer.
Of velocity a boost, and the larger the change of velocity, the larger the angle you turn from time to space. Now, as you all know, the speed of light is an upper limit. This means you can...
Says you. So again, we've never tried, so how do we know? And it's just a fact, okay? You can make arguments that it's really hard to get matter to move the speed of light, but I would argue that it really isn't impossible to get the matter to move the speed of light, because if you can get a single electron to go that fast, then you can get all the electrons to go that fast, theoretically. But the real point is the fact is that you can never undo the fact that matter doesn't have any capacity to move except when it's being pushed by a force, and you'd have to be pushed by an infinite number of force bits to actually move the electron at the speed of light. It's always going to be a little bit less. But so what? How does that have anything to do with this pretending that now that I've moved the electron at the speed of light or near the speed of light or even half the speed of light, that somehow the electrons doesn't go to the bathroom as often and it doesn't do anything else that it used to do, at a certain rate, that somehow all of its functions just stopped because it's moving fast. No reason to think so. No reason to think it's possible that such a thing could exist. That somehow the gravity and all the other magnetism, all the forces affecting it would all slow down in cooperation with the idea that because we're going fast, we have to pretend we're in a new, different universe and we're just being slowed down. All of our functions are slowing down. No, they're not. They're all made out of real forces moving the real speed of light, and you can't evade them. Just like your spaceship trying to move at a very fast speed can't evade the hydrogen atom that'll blow your spaceship up.
Not turn from moving only through time and standing still in space to moving only in space and not in time. That does not work. Instead, there's a maximal angle you can...
So this isn't gobbledygook, okay? Some silly angle between space and time. Oh, the special halfway angle. And that's as far as you can go. Can't go any farther than halfway between space and time. La 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 la. And that's not gobbledygook.
Turn in space-time by speeding up. That maximal angle is by convention usually set to 45 degrees. But that's really just convention. For the physics, it matters only that it's some angle smaller than 90 degrees.
So that's how accurate all this stuff is. It just doesn't matter. Just make it up.
The consequence of time being a dimension, as Einstein understood, is that time passes more slowly.
I don't think Einstein understood that, frankly. So you can say Einstein thought it was a dimension. I'm not and understood it as a dimension, but I don't know how he could possibly understand it as a dimension when it has none of the features of a dimension.
If you move relative to the case when you were not moving, this is the time dilation. How do we know this is correct?
The time dilation. This is the time dilation. Where you can pretend gravity stops, charge stops working, magnetism stops working, everything stops working, blah, 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 except everything stays the same. Photons still fly away at the same speed, even though you're going just as fast as they are, almost. They still fly away from you at the speed of light. No, they really don't. They fly away from you very, very fast. It's just that you're moving you're going so slow that you can't figure it out for a very long time.
We can measure it. How do you measure a time dimension? It turns out you can measure the time dimension with, guess what? The things we normally call clocks.
So we know we don't do it with clocks, okay? We do it with a specific kind of clock, and that's the only clock you've ever been able to make do this time dilating thing. So you never made a Timex watch do it. You never made some other kind of sundial do it. You never made any other physical clock except for a radioactive element or isotope do it. So all you've demonstrated is that radioactive isotopes delay their half-life is expanded by high velocity. And we already know that you can accelerate that rate of decay by just surrounding them with more radioactive elements. So we already know it's a process. It's not something we already know it's an environmentally caused event, because we already know we can change the environment that the little isotope is in, and we can change its half-life from once in 10,000 years to once in 2 years, just by surrounding it with like radiating bodies. So surrounding it with more radiation, it decays quicker. So we know it's triggered by environment. And clearly you're changing something's environment by moving it very fast. That means you have to put a gamma ray behind it. You have to put a bunch of energy behind it to push it.
The relevant point here is that this definition is no longer circular. We define time as a dimension in a specific theory.
Right, okay, so it's not circular, but it's just ludicrous because it doesn't have any of the features of a dimension. It can't be called a dimension. You can call it something else, but it can't be in the category of dimension because it doesn't have feathers, doesn't have a beak, doesn't fly, doesn't have warm blood, doesn't have eyes. It doesn't fit the category. So that somehow better than circular reasoning is completely disconnected from reality reasoning. I'm just going to pretend words don't mean anything anymore. Dimension doesn't mean dimension. Dimension means something else. And that's better than circular? No, that's just as bad as circular reasoning.
Clocks are what we call devices that measure this. How do clocks work? A clock is anything that counts how often a system returns to the same or at least a very similar configuration.
Right, and it only does that because of the environment. So if I change the environment for Old Faithful, that is, I cool the ground that of the geyser, I'll change how often Old Faithful bubbles up. So all I do is change the environment, I change Old Faithful, I break the clock. So all we're really talking about is how to break clocks. This doesn't have anything to do with any proof that time itself flexes and bends. No proof whatsoever that that happens ever, 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 ever.
For example, if the Earth orbits around...
If it's 10 o'clock here, it's 10 o'clock at the end of the universe. It's 10 o'clock everywhere. Okay, every place has, it's 10 o'clock. Now, they could call it something else. They could call it 11:15. It doesn't matter. It's 10 o'clock. And we can count the seconds. When 1 second happens here and it's 10:01 second, then it's 1 second over there, and it's 1 second over there, and it's 1 second over there. Time is the same everywhere because the speed of light is the same everywhere. And they don't have any evidence indicating anything else is true.
The sun once and returns to almost the same place, we call that a year. Or take a pendulum. If you count how often the pendulum...
Yeah, it'd be really great if you took one of these and put that in something very fast and see if you can fuck that up. And you'd understand how you fucked it up, right? So it depends on which way your velocity is. If your velocity is this way and the pendulum's swinging this way, well, you don't have hope of fucking it up. But if your velocity is in the same direction that they're swinging, well, then you might fuck it up a lot.
Is, say, at one of the turning points, that gives you a measure of time. The reason this works is that once you have a theory for space-time, you can calculate that the thing you...
Yeah, it's calculate. Okay, it doesn't matter if you get the wrong answers, though. And as I've demonstrated, they get the wrong answers all the time, and they don't care. Okay, their whole kinetic theory, their whole equation is a pile of absolute crap. Things with the same momentum, they'll sit there and tell you they have different energies. Just absolutely wrong. It's absolutely, fundamentally, clearly, they're getting wrong answers and they don't care. So when they talk about doing all these calculations, it doesn't have anything to do with getting the right answers. They don't care what the answers are. They just like doing the calculations.
Call time is related to the recurrences of certain events in a regular way. Then you measure the recurrence of these events to tell the past.
Right, so if you used a light clock, as Einstein did as his thought experiment, you prove his own theory complete nonsense. Because all you have to do is figure out that, the light falls, but it didn't really fall. The spaceship moved away from it. And so it's really, I don't have to make light bend on Earth in gravity to make the two things similar, because in space there was only one force, me moving the spaceship. On Earth there's two forces. There's the force of gravity and then there's the force of the Earth pushing you back up. Two forces different comparison than one force. So, but right there, the light clock is infallible in terms of telling you what your velocity is. You could sit there in the spaceship. Einstein's already admitted it. I could just sit there in the spaceship. I could watch the light hit the wrong spot on the wall, and I could say what time it is. I could say exactly how fast I'm going. It's a perfect speedometer for high speeds. So I've already debunked this whole notion that I can't tell the difference. Yeah, I can tell the difference. I can see if I'm moving or the other guy's moving, I can tell, because if I'm moving half the speed of light, that laser beam is going to fall down the side of my ship, and it's going to tell me the right answer. So this whole thing is just such bullshit. Right out of their own mouth, the argument is fallacious and nonsensical. Right out of Einstein's own thought experiment, he's already conceding, you can know. You can do an experiment that'll tell you that you're the one moving. Never mind. That's what he should have said. Never mind. Sorry. I wrote this paper when I was young and silly. So you really shouldn't be paying all that much attention. It was just silly shit, It's what young people do. They have silly ideas.
Of time. But then, what do physicists mean if they say time is not real, as for example Lee Smolin has argued?
Well, he's a real retard, because it's clearly a phenomenon, okay? There's just no doubt about it that the phenomenon is taking place of things happening not instantaneously. Clearly, things are not happening instantaneously. Clearly.
As I have discussed in a series of earlier videos, we call something real in scientific terms if it is a necessary ingredient of a theory that correctly describes...
Okay, so that's not gobbledygook. A necessary ingredient of a theory that correctly describes what we observe. Blah, 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 blah. It sounds like gobbledygook to me.
What we observe. Quarks, for example.
So we don't observe any of this stuff. So that's just a joke, right? So it's just more nonsense where they're sitting there pretending that they are observing something when no, they're just interpreting the observation. They have made the observation up. They never observed the wave function interfering with each other or any of that crap. And they've just made up a theory.
Are real not because we can see them, we cannot, but because they are necessary to correctly describe.
No, they're not even close to being necessary to any of that, so it's just more nonsense. Not even close to necessary. Not even close. I mean, not even a little bit necessary to understanding that what a proton and a neutron are. You don't need this crap inside.
Describe what particle physicists measure at the Large Hadron Collider.
Yeah, no, it's not what they measure. So again, they have an observation and they've made up a whole silly story about what the observation means. So because something goes this way instead of going this way, they've decided it's an anti. Where it could just be one of the things we know goes this way. It's just going a little faster.
Time, for the same reason, is real because it's a necessary ingredient for Einstein's theory of general relativity.
Oh dear. No, it's a necessary ingredient to make a video. You can't make a video, you can't eat a dinner, you can't breathe oxygen, you can't do anything if there's no time. And if everything happens automatically now, if it happened out there, it's over, it's done, and we already did everything. Yeah, if you already do everything instantaneously, then there's no time. So yeah, it's no universe with no time.
To correctly describe observations. However, we know that general relativity is not fundamentally the correct theory.
So this is the hilarious part. She just goes through this whole crap telling us it's a necessity for us to understand it this way. It's necessary that quarks exist or we can't get the right answers. And then she's basically going to say exactly the opposite. We don't have the right answer. So who knows? Circular? No, this is retarded. Okay, asserting a truth and then saying, no, not really the truth, never mind.
By this I mean that this theory has shortcomings that have so far not been resolved, notably singularities and the incompatibility.
Well, whatever. Singularity is just a silly concept in and of itself. Oh, the electrons are inside of the electron is inside of the electron is inside of the electron. When we know nothing does that in the real world, I can't put anything inside of other things that are already, the space is already filled. It won't fit inside. I can't make it go inside. It's just silly. There's no singularity, okay? There's just a condensation. You get to a certain point, and that's as compact as you can make it. You can't make it any more compact. They understand things like this, all right? They understand like water molecules are uncompressible, right? I mean, you could actually literally take the moon and put it on, put a little vial of water between us and the moon. The water will actually not compress. Even though the moon is sitting on it, it still won't compress.
With quantum theory. For this reason, most physicists, me included, think that general relativity is only an approximation.
Oh yeah, it's only an approximation. It's only a made-up pile of crap. It's only some sort of bizarre placeholder for a real answer. It's not even close to any of those things. It's crap. It's gobbledygook. It's nonsense. Yes, you're correct. It is a silly, stupid, useless answer because it doesn't really answer anything. It doesn't explain anything. It's not physical. It doesn't have any mechanics. It's, completely a religious story, essentially. So why are you arguing for it? To have any use at all. It has no use at all.
To a better theory called quantum gravity.
Yes, which is just more bibble-babble in the sense of they're going to turn gravity into a wave function. I mean, it's clearly not. It doesn't do any wavy stuff. It isn't going to have a frequency. Trust me, gravity is not going to have a frequency. Okay? Gravity is just the consumption. That's what happens when you trap all those little things pushing you. That's gravity, because now those little things were going somewhere, and they're not going to get where they're going if they're stuck pushing your little bits around. So your little bits get stuck getting pushed around, and the little bits are piling up, pushing your crap around, and therefore they're not doing what they could be doing out in the universe. So the truth is a bunch of force goes into the earth, and a bunch of force doesn't get back out because it's busy moving your matter, making your little bits bang into each other and do shit. And all of that has to take energy, and the energy is taken out of the environment, essentially consumed in a sense through time, and so the earth radiates less energy than it absorbs, and that's the gravity. There, quantum gravity solved, gravity figured out. Simple answer. More goes in than comes out because it's busy pushing rocks around. It's busy pushing electrons and protons around. Heavy little rocks have to be moved around, and to move them around, you have to use up something called energy. There, is that too complicated? No. Is that a simple, complete answer? Yes. Does it fail to answer the question in some way? No.
We don't yet have a theory of quantum gravity, but there is no shortage of speculations about what its property.
And right, they're just guesses and bullshit, and they're all based on wrong premises. So they've accepted a bunch of gobbledygook as a premise, as axioms, and then they're going to keep trying to force those axioms to be true. This wave theory nonsense, this field theory crap, all this mush about all these vacuous, non-existent, dimensionally crappy thingies, instead of just recognizing that it's momentum moving the speed of light. That's what exists in the universe. There's momentum moving the speed of light, and then there's clumps of harder stuff that doesn't do anything until the force tells it what to do. It doesn't go anywhere, it doesn't do anything until some kind of imbalance in the little shit forces it to. The universe is just tadpoles and clumps of shit, and the tadpoles bang into the shit, and the shit moves wherever the tadpoles hit it. Ugh.
This may be. And one of the properties that it may have is that it does not have time. So this is...
Oh, amazing. I mean, just amazing. When all of them are timed equations. I mean, they're just, the whole quantum mechanics is just full of equations that take place over time. It's the whole point of an integral. No, just too stupid.
What physicists mean when they say time is not real. They mean that time may not be an ingredient of the to-be-found theory of quantum gravity, or, if you're even more ambitious...
So let's understand, all this stuff happening at a frequency, right, that they're calling waves. Okay, it's just bullets at a frequency. But I mean, obviously it couldn't mean anything to have bullets at a frequency. Couldn't mean anything to have tipping points. Couldn't mean anything to have resonant frequencies. All that stuff couldn't mean anything without an understanding of a standard of time. That there's a standard amount of distance that this stuff can move in a certain amount of time. So you can't do any kind of quantum mechanics without time. It's just absolute nonsense. You couldn't sit there and show us this physics.
A theory of everything. Time then exists only on an approximate emergent level. Personally, I find it misleading to say that in this case time is not real. It's like claiming that because our theories for the constituents of matter don't contain chairs, chairs are not real. That doesn't make any sense.
Well, I don't know what you just said makes any sense. But, I mean, it's good that you're arguing against it, but what you're arguing for is just as ludicrous. Okay, your field theories and your dimensions and your other crap that don't mean anything, your wave functions, your non-physical virtual photon bullshit.
But leaving aside that it's bad terminology, is it right that
Yeah, virtual photon is bad terminology.
time might fundamentally not exist? I have to admit, it's not entirely implausible. That's because one of the major reasons...
It is to me, so it's totally implausible to me. Okay, there's no way I can make any plause out of it at all. Just doesn't make, oh, we're just going to pretend time isn't a key feature to the function of all of these mechanics. How fast something gets hot, how fast this happens, how fast it accel, how fast, I mean, all this stuff depends on how fast it does it. In what period of time it does it. I mean, that's what makes a photon, right? Is the period of time. it hits and then it hits again at a certain period of time, and it is critically important when it hits again. It makes a huge, gigantic difference to what's going to take place. It's completely dependent on how close those events are to each other in time.
That's why it's difficult to combine quantum theory with general relativity, is that time is a dimension in general relativity. In quantum mechanics, on the other hand, time is not a dimension. It's not even something you can measure. It's not...
Okay, so that's stupid to say. It's clearly a function. It's a loud and clear function. It's a thing happening in the context of any equation you're going to write up. Time is going to be relevant as a function.
And observable, as the physicists say. In fact, in quantum mechanics, it is entirely unclear how to answer a seemingly simple question.
No. Every single thing is a clock. So it's telling time all the time. Everything is telling time all the time. Every movement, everything it does in space is telling time.
Like, what is the probability for the arrival time of a laser signal? Time is treated very differently.
Yes, the probability again. So they're pretending that it happens because of some magical function that changed where it was in space, rather than accepting the obvious answer, which is, no, it's a group phenomenon. If there's any difference in the outcome, it happens because there's difference in what you put as the income. What you put in was different, and that's why you got something different out. Okay, the simple answer is different in, different out. So yes, your photon can go through the middle of the slit, or your photon can go right near the edge. You can get hit by an electron and end up going over there or over there. Yeah, it's two different outcomes because they were two different events that happened at the going in process.
These two theories. What might a theory look like in which time is not real? One possibility is that our space-time might be embedded into just space, but it has a boundary where time turns to space. Note how carefully...
No, that's not gobbledygook. Not at all. I mean, everybody can understand it. One thing turns right into... A bird turns into, whatever, elephant. Dumbo. There you go.
I have avoided saying before it turns to space. Before arguably is a meaningless word.
Right. We can just forget about the past and the future being different things. Like one already happening and one going to happen. Yeah, let's just pretend those are the same thing. Hasn't happened yet is the same as already did happen. Oh, fuck.
If you have no direction of time. It would be more accurate to say that what we usually call the early universe, where we expect a Big Bang...
Early universe? Early? Yeah. Anyway.
May actually have been outside of space-time, and there might have been only...
Maybe. It might have no gravity then. Maybe this, maybe that, maybe. Yes, maybe. But regardless, it doesn't matter. This is another one of those things where they're just assuming something based on one little piece of evidence, right? Redshift. So we've assumed all of this whole big giant theory about a Big Bang and a beginning and all this crap just based on one little shred of evidence, just one little tiny shred of evidence. Just so silly.
Space, no time. Another possibility that physicists have discussed is that deep down, the universe and everything in it is a network. What we usually call space-time is merely an approximation to the network.
Right, so we know that none of this stuff has any very real direct connections. That everything is connected to its surrounding environment. That's just a fact. Nothing can be near something else without being affected by that thing being near them, because they're going to reflect things into them that they wouldn't have got hit by if that thing wasn't there. All of that kind of crap. But there's no big connections. The big connections have to go through this insane process of starting with an electron and then inside of an atom with electron and proton, and then atoms stuck to each other based on their arrangement of electrons and protons, and then the whole mass of that. I mean, come on. The connections are so distant. It's local. The universe functions locally, all right, but by consistent space. It's all in the same space.
cases when the network is particularly regular. There are actually quite a few approaches that use this idea. The most recent one is Stephen Wolfram's hypergraphs.
Oh, yeah, it's hypergraph, blah, blah, blah. Look at this neat little picture, blah, 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 blah. Not gobbledygooky at all. No, that's not gobbledygook. No, 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 no. I can see right, boom, that's obviously a flying elephant. Or something like that. It does look like it has eyes, though. Maybe it's an ant's head. The skull of an ant? Skull? Yeah, I don't know. Skull of an ant. It doesn't really work, right? Because the ant's skull is on the outside. And that doesn't look exactly like an ant's skull. But what's just underneath the skull of an ant? Maybe that's what that is.
Finally, I should mention Julian Barber, who has...
Oh, why? Just mention any random crazy fuck with a silly idea, and none of them are going to have anything called a nice, rational, simple, stupid idea. No, it's not going to be a simple universe made out of crude, dumb, simple forces. It's always going to be a fanciful universe full of entangled ESP particles that don't know where they are.
Argued that we don't need time to begin with. We do need it in general relativity, which is the currently accepted theory for the universe, but Barber has developed...
Well, I mean, doesn't it sound right on its surface just pretty silly that you could explain a progression of events that are so time dependent without including time? I mean, it just doesn't seem to make, like, that could make any sense at all. You're calling time something else, right? I mean, the guy has a theory where instead of calling it time, he calls it smime. Smime, okay? Some smime went by, and this is how the universe looks at smime 2, smime 4, you know. But it still has to include the progression of events. That we already know that these are events that have to happen in a direction. Pouring the ink into the water, you know. Very different than sucking the ink out of the water.
Developed a theory that he claims is at least as good as general relativity and does not need time. Instead...
Did you test it or something? Or are you just suggesting it randomly or what? He says. Lots of people say stuff, okay? I mean, LIGO says they can measure 1/10,000th of the diameter of a proton. Do you think they can? Do you?
It is a theory only about the relations between configurations of matter in space which contain an order that we normally associate with the passage of time, but really the order in space by itself is already sufficient.
So he's just calling time order of events. So yeah, that's exactly what I said. It's just changing the word. He's just pretending I'll have time, but I just won't call it time. I'll just call it sequencing.
Barber's view is certainly unconventional, and it may not lead anywhere, but then again, maybe he's onto something. He has just published a new book about his ideas.
No, isn't that special? The Jantis point. He called it after himself. Isn't that special?
This video was sponsored by Brilliant.
Oh, I'm so frickin' pleased with that whole fucking pile of shit. Sponsors a lot of this crap, this gobbledygook. It's a big sponsor of gobbledygook on the internet. You know. Obviously something misnamed. It was actually Stinky Poo, okay? And then, you know, they had a theory. Oh, let's call it Brilliant instead. Even though it's Stinky Poo, let's call it Brilliant. Yeah. That'll be our theory.
Is a website and app that offers interactive courses on a large variety of topics in science and mathematics. If you want to understand better what space-time is,
well, you want to know what the basic lies are we tell, you know, the whole two-slit, two-wave theory that doesn't work at all, you know, the whole two-source interference radar thing that's just jamming, kind of obviously and overtly. Yeah, we'll tell you all those lies. We'll talk about detector experiments and all kinds of cool stuff. Spin, you know, yeah.
Are and how time dilation works, then Brilliant is a great place to start. To get more background on this video...
Jeez. They might as well just call it Bible. Bible. You know, this is just babble. Babbly little Bible book.
Content and to see how the math works, I recommend you...
The math actually doesn't work, remember. 1/2 mv squared. That doesn't work. Get you the wrong answer every time.
Look at their course on special relativity. It will teach you all you need to know about Einstein's ideas.
Oh, cartoon manner. Oh, I love cartoons.
Lorentz transformations, and the odd consequences that follow from that. To support this channel,
Yeah, I wonder if it tells you about the laser beam in the spaceship, where Einstein concedes the argument that he's full of shit. Because the photons will tell you the truth. The photons don't give a shit about relativity. The photons don't give a shit about your dimensional space and all your crap. They just do their thing, and they'll always let you know where you are. That's the great thing about photons. They'll tell you the truth.
and learn more about Brilliant, go to brilliant.org/Sabine and sign up for free. The first 200 subscribers using this link will get 20% off their annual.
Oh, how special. I just can't wait. Oh, yeah, I can wait. That's what I'll do. I will wait. I wonder how much he gets paid per video. Somebody suggested $500. Now, I'm offering $1,700, which is a lot more than $500. So at least you didn't have commercials in here. I mean, I see these little dead spots. I don't know. Maybe they're going to be commercials eventually, but I don't know.
Premium subscription. Thanks for your time. See you next week.
Nah, too bad. Whatever. I'm disappointed. Disappointed. So her videos really have turned into crap. Yeah. She's just fallen into the same old pattern of get a little bit of popularity and then just turn into a sappy bullshitter. Hi, YouTubers. I mean, you know, it'll only be another week or two and she's going to be in a Barney the Dinosaur suit. So anyway, gimmick. Gobbledygook and gimmicky gook. Just mountains of it. Yuck. It's like sticky. Ew. So anyway. So, till the next time and such. What the hell that's about. So anyway, yeah, we're done. All right. So till the next time and such and so forth and whatnot. I hit this button and I go. This has been a Draft Science video presentation. Till the next time and such.